Let's find theta in this cube that has a side length of 2. We're not going to specify units. You can see that theta is an angle that's formed in a right triangle, and this right triangle is in 3D. Imagine sitting in this little box and you're sitting in the corner of a wall. Here's your head, and you're sitting down with your legs spread out over here along this line. Now, is it possible to use SOH in 3D? And the answer is yes, we can. The bottom of a cube is a square, so this happens to be the same length as this, and we'll call this 2. This happens to be C, it's the hypotenuse, and this happens to be a right triangle on the bottom. Using Pythagorean theorem, we know that c squared is equals to a squared plus b squared. So c squared is equals to 4 plus 4, which is 8. This is great. We can find the length of base c, which happens to be the square root of 8. Or if you really want, you can rewrite this as 2 times 2 times 2. And using rules for square roots, it takes 2 friends to break out, so we have 2 root 2 is equivalent to root 8. So either answer is fine. Now let's focus on the height of the square. We know this is 2, and so is the height. So we have 2 here. And now focusing on this 3-dimensional right triangle, the one involving theta, what can we say? We have c, which happens to be, let's just erase this, 2 root 2, I'll just call this root 8. It's good enough for our purposes. And we have 2 over here. What is theta? How do you find theta? We're interested in the opposite and the adjacent. Tan theta is opposite over adjacent, TOA. So tan theta is equals to the opposite, which happens to be 2 over adjacent, which is root 8 or 2 root 2. It doesn't really matter. So how do you find this golden egg theta? You simply take the trig inverse of both sides. So theta is equals to tan inverse of 2 over root 8. Using our calculator, we get 35.3 degrees. So congratulations, now you know how to deal with SOH CAH TOA beyond 2D. You can now answer 3D problems as well. Let's practice one more 3D problem. Imagine you are looking across a body of water, perhaps a river, and there's a hill. This hill is perpendicular. It goes straight up, and the question is, find h. Find h, the height of the hill. Now you're standing across a friend, and the distance between the two of you is 10 meters. Now, this person, when they turn their head to the right 60 degrees, they see the base of the hill. So this here is the water, and they turn their head to the right. The person's nose is pointing towards the base. And another thing is when the person tilts their chin up, when they're looking upwards, up to the sky, they just have to tilt their head up with an angle of elevation of 20 degrees to get a view of the top of the hill. Can we use math to solve h? Let's try. We're going to start off by looking at this bottom triangle, and we're going to focus on x. So looking at x here, we're dealing with this angle 60, and we're interested in adjacent and hypotenuse. SOH CAH TOA, adjacent and hypotenuse. So we'll say cosine of 60, this is the bottom triangle here, is equals to adjacent, which is 10 over the hypotenuse, which we don't know. We'll call this x. Now look here, we have simply one unknown variable and an equation. We'll say x is equals to the numerator divided by the other side. We'll just use our calculator for now. This is approximately, or rather, exactly 20. So this is amazing. We now know the base of this triangle, which is 20. So let's just erase this, and let's write in 20, going across this way. Alright, now let's focus on this triangle here. If you're sitting on the corner, you realize this is a right triangle. Imagine your head's here, you're sitting down with your legs across at a 90-degree angle. So this here also is a right triangle. And we're interested in the opposite and the adjacent. We're interested this time in TOA. So tan of 20 degrees is equals to the opposite, which is h, what we're trying to find, over the adjacent, which happens to be 20 meters perhaps. We multiply both sides by 20, so h is equals to 20 times tan 20 degrees. And using our calculator, we finally get our answer. The height of this hill is 7.28 meters tall.